Have you ever made a choice so small that it felt completely meaningless, like turning left instead of right, answering a message 5 minutes later, taking one train instead of another, and then later realizing that one tiny decision changed everything? I think about this more than I probably should. Last winter, I missed my usual subway train at Atlantic Avenue by maybe 30 seconds. Watched the doors close right in front of me, stood there on the platform, slightly annoyed, slightly resigned, the way you get when New York just does what New York does. So I waited for the next one, got on, sat down across from a woman reading a book I'd been meaning to read for 2 years. We ended up talking for 6 stops, and something about that conversation shifted how I was thinking about a project I'd been stuck on for months. Now, here's the thing. I'm not trying to tell you a feel-good story about fate or serendipity or the universe sending you signs. That's not what this video is about. What I'm actually interested in is something far more unsettling, because here's the question that's been sitting at the back of my mind ever since. What if missing that train wasn't really a choice? What if every single thing that happened that day, the 30-second delay, the conversation, this video, your decision to click on it, was already, in some deep physical sense, fixed? Not fixed by God, not fixed by destiny in some mystical sense, not by some cosmic plan written in the stars, but fixed by the structure of reality itself, by time. And I don't mean fixed in the way people usually mean it when they talk about fate. I mean something more specific, more scientific, more difficult to dismiss. I mean that the physics we have, the physics that has been tested, confirmed, and built into the technology you use every single day, that physics suggests a picture of time that is radically different from the one you carry around in your head. A picture in which the future is not waiting to happen, in which it may already, in some very real sense, exist. And if that's true, even partially, even approximately, then the most basic assumption you make about your life, about your choices, about who you are and what you're doing here, that assumption is standing on much less solid ground than you think. We live our lives as if the future is open, as if it's a blank page sitting out there ahead of us, waiting to be written. We feel the present as vivid and real and immediate, this exact moment, the one you're in right now, and we experience the past as something that's over, gone, sealed. Memory is all that remains of it. That's the intuitive picture, and it feels so obviously true that most of us never think to question it. But physics, particularly the physics that came out of the early 20th century and has only gotten stranger since, quietly suggests something far more uncomfortable. What if the past is not gone? What if the future is not unwritten? What if time is not actually moving, and the feeling that it is, the feeling of the present rushing forward, of moments coming into existence and then disappearing? What if that's just the way consciousness experiences a structure that is, in physical terms, completely static? What if right now, this moment, and every moment of your life that hasn't happened yet, what if all of it already exists? That is not a metaphor. That is not a philosophical thought experiment designed to sound deep. That is a real implication of real physics. And by the end of this video, I want you to feel genuinely unsettled by it. Not because it's scary in the cheap sense, not because it's some conspiracy or hidden truth that scientists are concealing, but because if it's true, even partially true, then the most basic assumption you have about your life, about your choices, about who you are and what you're doing here, gets much harder to hold on to. Let's start at the beginning. Let's start with why time feels like what it feels like. Because that, it turns out, is a much stranger question than it seems. Think about the way you experience time on an ordinary day. You wake up. There's a sequence. Coffee, subway, the grinding forward motion of hours. By the time you're lying in bed at night, you've crossed a certain distance. Time has passed. You can feel it. Not like you can feel heat or cold or pain, but in some way that's just as immediate, just as undeniable. Time feels like a river. You're in it, you're being carried by it. The current moves in one direction, always forward, never back. The future is somewhere downstream, out of sight. The past is upstream, where you can't return, and the present is the water right around you, the only real place. This is so deeply embedded in human experience that almost every culture in history has described time this way, as movement, as flow, as direction. Ancient Greeks talked about the river of time. The Hindu tradition describes time as a great wheel turning forward. We still carry that language. We spend time, we waste time, we lose time, we make time, we kill time. The words themselves treat time like a resource being consumed by a current you can't stop or reverse. And when someone dies, we say they're gone. When something is over, we say it's in the past. When something hasn't happened yet, we say it's coming. The entire architecture of how we talk about existence is built on this picture. Time flows. The present is real. The future is open. Now add to this the feeling of the present moment itself. The now, that immediate, vivid, undeniable sense of being here, in this second, in this specific slice of reality. Philosophers call this the specious present, the felt duration of now. And it feels like the most real thing there is, more real than memory, which is reconstruction, more real than anticipation, which is imagination. The present is the only place where experience actually happens. For most of human history, that wasn't just a feeling, it was physics. Before Einstein, the dominant scientific framework was Newtonian mechanics. And in Newton's universe, time was simple, time was absolute. It ticked forward at the same rate everywhere, for everyone, always. Whether you were standing still or moving fast, whether you were on Earth or drifting in deep space, whether you were in 1700 or 1900, the cosmic clock ran at the same speed for everything, everywhere. Every moment in the universe was the same moment, shared by everything in existence simultaneously. There was a universal now, a single shared present that encompassed all of reality at once. There was a kind of beauty to that, a kind of order. The universe as a vast, perfectly synchronized machine. Every clock in every corner of reality pointing to the same second. All of creation experiencing the same now, together simultaneously. And for everyday life, for building bridges, predicting the paths of cannonballs, calculating the orbits of planets, it worked spectacularly well. Newtonian mechanics is still what we use when we build buildings. It's still what NASA uses for most orbital calculations. It's extraordinarily accurate for anything moving at everyday speeds. But it was wrong, not a little wrong, fundamentally, structurally, completely wrong about the nature of time. Then came Einstein, and he didn't just correct Newton. He demolished the entire Newtonian picture of what time is. It's 1905. Einstein is 26 years old, working at a patent office in Bern, Switzerland. No university position, no fancy lab, no team of assistants, just a desk, a lot of physics papers, and apparently a mind that couldn't stop asking uncomfortable questions. The uncomfortable question he was sitting with and had been sitting with since he was 16 years old was something like this. What would it look like to ride alongside a beam of light? If you could match the speed of light, if you were traveling right alongside a light wave, what would you see? Would the light appear frozen? Would it look like a stationary wave of electromagnetic energy oscillating in place? It sounds like a thought experiment for children, an idle fantasy. But when Einstein actually followed it seriously, rigorously, mathematically, the answer shattered the entire Newtonian picture of reality. Not just about light, about time itself. Here's the setup that broke everything. We know light travels at a speed, a very specific, very fast speed, approximately 299,792 kilometers per second in a vacuum. And the bizarre thing that James Clerk Maxwell's equations of electromagnetism were suggesting, the thing that was making physicists deeply uncomfortable at the turn of the century, was that this speed appeared to be constant, not relative to anything, not relative to the source of the light, not relative to the observer, just constant, fixed, always the same, which makes absolutely no sense in a Newtonian world. Here's why. If you're on a train moving at 100 kilometers per hour and you throw a ball forward at 50 kilometers per hour relative to the train, then someone standing still on the platform sees that ball moving at 150 kilometers per hour. Velocities add together. That's intuitive. That's Newtonian mechanics. That's how the universe has always seemed to work. So, if light moves at a fixed speed and you accelerate toward a light source, shouldn't you measure the light as coming toward you faster? And if you accelerate away from it, shouldn't it appear slower, the way a police siren sounds, lower pitched as the car drives away? No. And this is the thing that was driving physicists to distraction. Every experiment done to test this, the most famous being the Michelson-Morley experiment of 1887, came back with the same bizarre, inexplicable answer. The speed of light is the same regardless of how you're moving relative to the source. You could be standing still or flying toward the light at half the speed of light, you'd still measure exactly the same value. Always 299,792 kilometers per second. Always. This is like standing on a moving train, throwing a ball at a wall, and finding that the ball travels at exactly the same speed whether the train is stopped or going 500 miles an hour. It makes no sense. It violates every intuition we have, and yet for light, it appeared to be absolutely, undeniably, experimentally true. Most physicists at the time tried to explain this away. Maybe there's some mysterious medium, the ether, that light travels through, and Michelson and Morley just measured it wrong. Maybe there's some physical contraction of measuring instruments that masks the true variation. There were many attempts to preserve the Newtonian picture while accommodating these strange results. Einstein didn't do that. He took a different approach entirely. He said, "Let's take this seriously. Let's not try to explain it away. Let's say the speed of light really is constant for all observers, regardless of their motion. And then let's ask, what does that require? What must be true about the universe for this to be possible? What it requires, it turns out, is that time itself cannot be constant. If the speed of light is the same for everyone, if no matter how fast you move, you always measure light traveling at 299,792 kilometers per second, then the only way that can be mathematically consistent is if time runs at different rates for observers in different states of motion. Speed is distance divided by time. If the distance part stays fixed and the time part changes, the speed stays constant. That's the only way the math works. And so Einstein concluded, time is not absolute. Time is not the same for everyone. Time is flexible. It bends, it stretches, it depends on how you're moving. This is not a metaphor. This is not a convenient fiction. This is the literal, physical truth about the universe we live in. And here's where it gets strange. And I want to make sure you actually feel how strange this is, because it's the kind of thing you can read about and nod at without it really landing, without it really changing how you understand reality. Imagine two people. One is standing still. One is moving very fast, let's say close to the speed of light in a rocket ship. Both of them have perfect clocks. Atomic clocks, let's say, accurate to a billionth of a second. Both of them observe a flash of light. Because the speed of light is the same for both observers, because that's what Einstein built into the very foundation of his theory. The time it takes for the light to travel a certain distance must be different for each of them. If they both measure the same speed for the light and they're in different states of motion, covering different distances in the same elapsed time, then the time they measure cannot be the same. The clocks must be ticking at different rates. This is time dilation, and it is not a theory. It is not a speculation. It is not a calculation that might be real in some exotic situation you'll never encounter. It is empirically confirmed, tested, measured, and verified over and over again with increasing precision, using increasingly sophisticated instruments. Here's a real example. GPS satellites orbit the Earth at high speed, roughly 14,000 kilometers per hour. Because they're moving fast relative to us on the surface, their clocks run slightly slower, about 7 microseconds slower per day, due to this velocity effect. But they're also much further from Earth's gravitational field than we are, and gravity also affects time. In stronger gravity, time runs slower. Being further from Earth's mass means being in weaker gravity, which causes the satellite clocks to run faster, about 45 microseconds per day, faster than clocks on the surface. The net effect is a discrepancy of around 38 microseconds per day. That sounds tiny, but if GPS systems didn't correct for this, if they just assumed that time ticks at the same rate everywhere, as Newton said, your phone's navigation would accumulate an error of about 10 kilometers per day. Your maps would be off by miles within hours. The system would be useless for navigation within days. We correct for relativity every single day. It is baked into the technology billions of people depend on constantly. Time dilation is not a thought experiment. It is an engineering requirement. But GPS is a small case. At the relatively slow speeds of satellite orbits, the effects are measurable but modest. The really mind-bending version of this is what happens as you approach the speed of light. The famous thought experiment here is the twin paradox. Imagine two twins, born on the same day. One stays on Earth, one gets on a spacecraft, travels at close to the speed of light for what feels to them like a few years, then turns around and comes back. When they reunite, the traveling twin is younger. Not metaphorically younger, not just subjectively younger, actually, biologically, physically younger. Less time has passed for them. Their cells have divided fewer times. Their neurons have fired less often. If they kept a diary, it has fewer entries. Their hair has grown less. Their body has aged less. They experienced less time, period. Not because of anything biological, not because of any effect of the journey on their body, because of the geometry of space-time, because of the mathematics of how time works for objects in different states of motion. I try to really sit with this sometimes. I was thinking about it last month, riding the F train back from Manhattan late at night, and I had this moment of just, wait, if I had spent the last hour traveling at a significant fraction of the speed of light instead of sitting on this subway, I would be measurably, physically younger than everyone I know. Not by much, but the difference would be real. Actual time would have passed differently for me. The train I was on was going maybe 50 miles an hour. The relativistic effects were there. They're always there. But they were so small as to be completely negligible for any practical purpose. But the principle is real, and it means something deeply disorienting about what time actually is. If time can run at different rates depending on how you're moving, if your clock and my clock can genuinely, measurably tick at different speeds, then time is not a universal background feature of reality. It's not the cosmic river that carries everything equally. It's not Newton's absolute clock. It's something more like a local property, something that belongs to a particular observer in a particular state of motion, something that depends on you, on your velocity, on where you are in a gravitational field. Time is not fixed. Time is not shared. Time is not the river we all swim in together, and that's still just the beginning. There's a word we use constantly. It's in almost every sentence about time, in almost every way we talk about experience and reality and being alive. Now. Right now. This moment. The present. The thing that separates what has already happened from what hasn't happened yet. The thing that feels most fundamentally, undeniably, immediately real. Now is so obvious that questioning it seems almost absurd. Of course there's a now. You're in it. I'm in it. The person next to you on the street is in it. Everyone alive is in it together. Except we're not. And this is, in my opinion, the single most disturbing implication of Einstein's special relativity. More unsettling than time dilation. More unsettling than the twin paradox, because those at least feel like they're happening to someone else, to twins in spacecraft, to satellites in orbit. This one cuts right into the assumption you carry about your own experience. It's called the relativity of simultaneity. Here's what it means, and I want to be careful here because this is genuinely strange and it's easy to nod along without it registering. Suppose you're standing in the middle of a very long train car. There's a light bulb exactly in the center of the car, equidistant from both ends. It flashes. From your perspective, standing in the middle, the light travels equal distances to reach both ends of the car. It reaches both ends at exactly the same moment, simultaneously. That makes sense. That's straightforward geometry. Now imagine someone watching from a train platform as your train moves past them at high speed. They see the same light flash from outside the train. From their perspective, here's what's happening. The back end of the train is moving toward the point where the light flashed. The front end of the train is moving away from it. So the light doesn't have to travel as far to reach the back end. The back end is coming toward it. But it has to travel further to reach the front end. The front end is running away, and because the speed of light is the same in both directions, that fundamental constant we established, the light reaches the back end of the car before it reaches the front end. From the platform observer's perspective, the two events are not simultaneous. They happen at different times, not by much at everyday train speeds. The difference would be unmeasurably small. But in principle and in practice, at speeds approaching the speed of light, the two events that were perfectly simultaneous for you are definitively, provably not simultaneous for the person watching from the platform. And here's the critical, crucial part. Both of you are right. There is no privileged frame. There is no external vantage point that settles the question of which one has the correct answer. Simultaneity is not an objective fact about the universe that some observers get right and others get wrong. It is relative to the observer. It literally depends on who is doing the measuring, which means there is no universal now. Let me say that more directly, because it's easy for it to just wash over you like another physics factoid. Right now, this second, as you're watching this video, there are events happening in distant parts of the universe, in other galaxies, billions of light years away, and the question of what is happening right now at this exact moment in a galaxy a billion light years away does not have a single correct answer. It is not that we don't know the answer. It is that the question itself doesn't have a well-defined answer independent of the observer. It depends entirely on your state of motion. Different observers, moving at different velocities relative to each other, would give completely different and equally valid answers to that question. For one observer on Earth, a particular star in a distant galaxy might be exploding right now. For another observer, on a spacecraft moving away from Earth at a significant fraction of the speed of light, that same explosion might be happening centuries in the future. It hasn't happened yet, from their equally valid perspective. For a third observer, moving toward that galaxy at high speed, the explosion might have happened centuries ago. It's already in the past. all three are correct. All three are giving accurate descriptions of reality from their reference frame. And there is no higher authority that adjudicates between them. That means the word now, the thing that feels like the most obviously real feature of your experience, the thing that feels like the ground of your existence, does not correspond to any single universal feature of the physical world. It's not a fact about reality out there. It's a fact about you, about your particular position and velocity in the structure of space-time. I've been sitting with this idea for a while, and I still find it genuinely difficult to fully absorb. I was having coffee near my apartment the other morning, one of those gray Brooklyn winter mornings where everything looks slightly out of time, and I thought about it. Right now, I'm here. But what does right now mean for something happening in a galaxy 10 billion light years away? What is the universe doing over there in my now? And the answer is, that question doesn't have a single correct answer. My now doesn't reach that far in any meaningful physical sense, which raises an immediate, deeply uncomfortable follow-up. If there's no universal now, if different observers can disagree equally validly about what's happening simultaneously, then what is the structure of reality? What holds it all together, if not a shared present? Here's where the physics leads us somewhere even more radical. In Newtonian physics, space and time were separate things. Space was the arena in which events happened, three-dimensional, geometric, fixed. Time was the clock that measured when they happened, one-dimensional, universal, absolute. They were independent. You could talk about space without talking about time and vice versa. But Einstein's relativity does something remarkable, something that still feels conceptually strange more than a century later. It fuses them. What we call space-time is a four-dimensional structure, 3 dimensions of space plus 1 of time, that exists as a unified whole. It's not that space and time are different aspects of the same thing, the way north and east are different directions on a map. They're more deeply merged than that. Mathematically, physically, fundamentally inseparable. When you move through space, you necessarily also move through time, and the rate at which you move through time depends on how fast you move through space. They're not two separate things happening in parallel. They're two aspects of one thing. Hermann Minkowski, who had been Einstein's professor at ETH Zurich, worked out the mathematics of Einstein's special relativity and arrived at this picture of a unified four-dimensional structure. In 1908, he gave a famous lecture in which he declared, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." He said that in 1908, more than a century ago, and the strange thing is, we still haven't fully metabolized what it means. We still talk about space and time as if they're separate. We still experience them as separate, but they're not. Because if space and time are a single four-dimensional structure, then the way we think about the present, as a razor-thin slice of time separating the past from the future, becomes much more complicated. Think about a map. A map is a two-dimensional representation of space. You can pick any location on it and look at it. Paris, Tokyo, Lagos, Brooklyn, they all exist on the map simultaneously. Right now, at this moment, Paris is there and Tokyo is there, and you can look at either one. The map doesn't create Paris when you look at it. It doesn't make Tokyo cease to exist because you're looking at Brooklyn. Every location exists as a permanent, simultaneous feature of the map. Now, extend that idea. Add 2 more dimensions. Include time. If space-time is a structure, if it's something that exists as a whole, rather than a sequence that unfolds, then every point in time is analogous to a location in space. Different times are like different places on the map. They all exist simultaneously as part of the same structure, Past events, present events, future events, they're not a sequence that unfolds, they're coordinates in a four-dimensional structure. They don't come into existence as time flows, they're just there, all of them. This is what physicists call the block universe, and it is one of the most disturbing ideas I have ever spent serious time with. The block universe, sometimes called eternalism in philosophy, is the view that the universe, considered as a whole, is a four-dimensional block. Every event that has ever happened is happening now and will happen in the future. All of it exists as part of this structure. The Big Bang is in it. The formation of the earth is in it. The first moment of your life is in it. This moment right now is in it. And whatever you'll be doing in 20 years is in it too. The block does not grow. The future is not being added to it moment by moment. It does not have a moving present built into it. It does not have a now. The feeling that time is moving, that the present is special, that the future is open and unwritten, none of that is a feature of the block itself. It's a feature of consciousness, of the particular way that beings like us experience the structure from the inside. Think of it this way. Imagine a DVD of a movie. The entire movie is already there, on the disc, encoded in the physical structure of the disc. Every scene, every line of dialogue, every moment, the beginning and the middle and the ending all exist simultaneously on the disc. The disc doesn't create the next scene when you reach it. It doesn't make the previous scene cease to exist once it's passed. All of it is there, always, all at once. When you press play, you experience the movie as unfolding, as moving forward, as a sequence of moments, each one replacing the last. The experience of watching the movie is genuinely sequential, but that sequence is not a feature of the disc. It's a feature of the playback. Consciousness might be the playback. The block universe might be the disc. Or think of it like a book. Every page of the book already exists when you open the cover. Chapter 1 and Chapter 20 and the final page all exist simultaneously. The story doesn't unfold. You move through something that already exists in its entirety. The ending is there before you reach it. The character's fate is already inscribed before you read it. If the block universe is correct, then every moment of your life, including the moments you haven't lived yet, already exists in the structure of reality, not waiting to happen, not approaching from some metaphysical future, already there, already real, just at coordinates that you, from your current position in the structure, cannot access. Your first memory exists. Your most recent conversation exists. The conversation you'll have tomorrow exists. The last thing you'll ever say to someone you love exists. The moment of your death exists. Not in the future, in the block. I want to sit with that for a moment before we go further, because I think it's important to feel what that actually means, rather than just nod at it as a physics concept and move on. Last fall, I was sitting at my desk late at night, probably too late, the coffee long since gone cold, working on something that wasn't coming together. And I looked out the window at the Brooklyn streetlights and had this moment of a very specific kind of vertigo. I thought, if the block universe is real, then the version of me who finishes this, who figures out what's wrong with it and gets it right, that version doesn't just exist in some possible future. That version already exists in the structure of space-time, right now, at a coordinate I can't see from here, but that is as physically real as the coordinate I'm at now. And then a darker version of the same thought. What if the version of me who never figures it out, who gives up, closes the laptop, goes to bed, what if that version already exists too? What if both futures are already there, equally real, and I'm just here in the middle, not yet at either coordinate? That thought sat in my chest in a way that was hard to shake, because it felt like the question wasn't what will I do? It was something closer to What do I do? Present tense, as if the verb itself was already fixed, as if I was already somewhere on the disc, and the question was just which scene I was at. Now here's the obvious objection, and it's a good one. I want to take it seriously rather than wave it away. Even if the physics suggests that spacetime is a static four-dimensional block, even if the math is telling us that there's no universal flowing present, we clearly, viscerally, undeniably experience time as flowing. The sensation of the present moment moving forward, of the future becoming the past, of now being constantly renewed. That experience is as vivid and immediate as anything there is. It doesn't feel like an illusion. It feels like the realest thing in the world. If the block universe is real, where does that experience come from? Why do we feel time flowing if it isn't? This is actually one of the genuinely open questions at the intersection of physics, philosophy of mind, and neuroscience. And the answer is not settled. But there are some things we can say. The most common response from physicists who take the block universe seriously is essentially this. Time appears to flow because of how our brains process information. We're built to experience events sequentially. Our neural processing is inherently ordered. One thing happens, then another, then another. We form memories in one direction only. We remember the past, not the future. And the structure of that sequential processing creates the sensation of a moving present. The feeling of now rushing forward might be what it's like to be a conscious system that processes information in one direction, embedded in a four-dimensional structure that has no built-in direction at all. But that raises an immediate follow-up. Why do we only form memories in one direction? Why can you remember yesterday but not tomorrow? And this question leads us straight to one of the most important and least appreciated ideas in all of physics. Here's something you've probably never thought about: the fundamental laws of physics. Newton's laws of motion, Maxwell's equations of electromagnetism, Einstein's relativity, even most of quantum mechanics are, at a deep mathematical level, time-symmetric. What that means is this: if you filmed a physical process governed by these laws, any physical process, and played the film backward, the backward version would also be a valid physical process according to those same laws. Film a planet orbiting a star, play it backward, a planet orbiting a star in the opposite direction. Still completely valid physics. Two billiard balls colliding and bouncing apart, play it backward. Two billiard balls approaching each other and bouncing apart. Still valid. A pendulum swinging, play it backward. Still valid. The equations that govern these processes don't pick out a forward direction for time. They're equally valid running forward or backward. Time reversal symmetry is built into the foundational laws, and yet we experience a very clear, very consistent, completely undeniable arrow of time. Things happen in one direction, always, without exception. A broken glass does not spontaneously reassemble itself. A cold cup of coffee does not heat itself back up. Smoke does not converge back into an unlit candle. A scrambled egg does not unscramble. Ice does not form spontaneously in a warm room. Why? If the fundamental laws are time-symmetric, why does everything we experience point in one direction? The answer is entropy. Entropy is a measure of disorder. More precisely, and this is the important version, entropy is a measure of how many different microscopic arrangements of a system's components would produce the same macroscopic appearance. Think about a room. If the room is perfectly tidy, books arranged alphabetically, every object in its designated place, there are very few arrangements of the objects that would look like this particular tidiness. But if the room is messy, there are enormously many ways the objects could be scattered around while still appearing messy. Mess is more probable than order simply because there are more ways to be messy than to be tidy. The second law of thermodynamics says that entropy in a closed system tends to increase over time. Things become more disordered, not because of any active force pushing toward disorder, simply because disorder is more probable. Random changes will almost always take you from a less probable state to a more probable one, from order to disorder, from tidiness to mess. Think about a fresh egg. In its intact state, it's a highly specific, highly organized structure. The shell is intact. The yolk is in place. The white is where it belongs. There is essentially one way, or very few ways, for all the molecules involved to be arranged while still constituting an unbroken egg. But once you drop it, once the shell shatters, the yolk spreads, the white disperses across the floor. The number of possible arrangements of those same molecules explodes into almost incomprehensible vastness. There are almost infinitely more ways for an egg's molecules to be spread around in a broken configuration than there are for them to be organized into an intact egg. That's why broken eggs don't unbreak. Not because it's literally forbidden by the laws of physics. The underlying physics would permit it. If you could reverse the velocity of every single molecule in the broken egg simultaneously, it would, technically, reassemble. But the probability of that happening spontaneously through random thermal motion is so astronomically, incomprehensibly small that in any practical sense, it never happens. Entropy increases, disorder increases, and our experience of time's direction tracks this increase. We remember the past and not the future because our memories are low entropy records of prior states, organized neural patterns encoding what happened, and those records only form in the direction of increasing entropy. Cause comes before effect because causal processes move from lower entropy to higher entropy. The arrow of time is the arrow of entropy. But here's what's important for our purposes, the thing that matters for understanding the block universe. The arrow of time we experience, the one-way direction of past to future, is not built into the fundamental laws of physics. It's a consequence of where we happen to be in the entropy landscape of our universe. Which means this: the fact that we can't remember the future is not evidence that the future doesn't exist. Let me say that again, because it's the key move. We often assume that our inability to remember the future means the future isn't real yet, hasn't happened yet. But our inability to remember the future is just a consequence of the direction of entropy. It's a constraint on how information flows in our universe, not a fact about whether the future exists. You can't access the pages of a book that are behind you when you're reading forward through it. That doesn't mean those pages don't exist. It just means you haven't reached them yet. Or rather, that your position in the book means they're in a direction you can't currently see. Our inability to remember the future might be exactly like that. A constraint of our position and direction in a structure that already contains everything. Past, present, and future. All of it inscribed. All of it there. Just not all of it accessible to us from where we are. Now let's bring this together, because we've been building toward the question that I think actually matters to most people watching this. The question that's underneath everything we've been talking about. The question of control. The question of choice. Because if the block universe is real, if the future exists in the same sense that the past exists, just at different coordinates in the space-time structure, then the disturbing implication is not just philosophical. It's not just an abstract puzzle about the nature of time. It's personal. It's about your life, your decisions, your sense of who you are and what you're doing. If the future already exists, does that mean you can't change it? This is determinism, and it's been haunting philosophers and scientists for centuries. But the block universe gives it a new physical dimension, a dimension that's hard to escape by just gesturing at mystery or possibility or the open-endedness of things. Let me introduce you to Laplace's demon. In 1814, the French mathematician Pierre-Simon Laplace, one of the most brilliant mathematical physicists in history, proposed a thought experiment that has echoed through science and philosophy ever since. Imagine, he said, a being, a vast intellect, that knows the precise position and velocity of every single particle in the universe at some particular moment, and knows all the forces acting on every one of them. Given that complete knowledge, this intellect could, using the laws of Newtonian mechanics, calculate with perfect accuracy the state of the universe at any future moment and any past moment. Everything would be perfectly predictable. Every event, every explosion, every biological process, every thought in every human brain, every decision that has ever felt free and autonomous would be the mathematically necessary consequence of prior states, traceable back through the entire causal chain to the beginning. Nothing would be free, nothing would be open, nothing would be genuinely undetermined. Everything would be, in the deepest sense, already decided. Laplace's demon can't actually exist. You'd need more computational resources than the universe contains to run that calculation. And there are deep reasons related to chaos theory and quantum mechanics why, even in principle, it would fail. But, as a conceptual argument, as an illustration of what classical physics implies about the nature of causality, it's extraordinarily powerful. And here's what I want you to notice. The block universe is essentially what Laplace's demon's calculation would reveal, if you could run it. It would show you that the future is not a space of open possibilities. It's a fixed structure, determined by the present state of things, which was determined by the state before that, which was determined by the state before that, all the way back to the beginning. The block universe and Laplace's demon are two faces of the same deep idea that the universe might be, at the most fundamental level, a complete and fixed structure with no genuine openness built into it. Now, at this point, almost everyone wants to raise quantum physics, and I want to address this carefully and seriously because it matters and it's often handled sloppily. The standard response to hard determinism, the thing people reach for when they want to feel like the future is genuinely open, is quantum mechanics. The argument goes like this: quantum physics is inherently probabilistic. At the subatomic level, events genuinely don't have determined outcomes. When a radioactive atom decays, is not determined by any prior cause, not even in principle. When a photon passes through a double slit, where it lands is genuinely probabilistic. The universe, at its deepest level, is fundamentally random. So Laplace's demon is impossible. So the future is genuinely open. So determinism is false. This is a real and important argument. At the quantum level, the universe does appear to be genuinely indeterministic. This is not just our ignorance, not just hidden variables we haven't discovered yet. According to our best current understanding, confirmed by decades of increasingly sophisticated experiments, quantum events involve genuine irreducible probability. Randomness is apparently woven into the fabric of things. So strict Laplacian determinism does appear to be false. The future is not completely predictable, even in principle. But here's the thing I want you to sit with carefully, because this is where people often take a false step. Does quantum indeterminacy, does fundamental physical randomness actually give you what you want? When you imagine having free will, when you imagine that your choices are genuinely yours, what are you actually imagining? You're imagining that you are the author of what happens. that your deliberation, your weighing of reasons, your values, your reasoning process, that you are what determines the outcome. Randomness doesn't give you that. If your decision about whether to take the job offer or turn it down is ultimately determined by some genuinely random quantum fluctuation deep in your neurons, some probabilistic event that could have gone either way with no cause determining which, then your choice isn't unfree because it was predetermined. It's unfree for a completely different reason, because it was random. You didn't determine it. Chance did. A random process is not a free process in any meaningful sense. A quantum coin flip is not your choice. It's the universe's coin flip happening inside your skull. So here's the uncomfortable position we find ourselves in. Neither a fully deterministic universe nor a genuinely random universe obviously gives us what we care about when we say we're free. Deterministic. Your future is fixed by prior causes, and you're executing a script you didn't write. Random. Your future is genuinely open, but you're not the author. The randomness is. What we seem to want, what free will feels like from the inside, is something like this. The future is genuinely open. There are multiple real possibilities, and my values, my reasoning, my character, am what navigates between them. Genuinely open, but genuinely authored by me. Whether anything like that exists in the universe as described by our best physics is one of the hardest problems in philosophy of mind. And the honest answer is, we don't know. We really don't. But here's something else worth noticing. Even if quantum randomness is real, even if the future is not perfectly calculable, that doesn't obviously refute the block universe picture. Some interpretations of quantum mechanics, particularly the many worlds interpretation developed by Hugh Everett in the 1950s and now taken extremely seriously by many physicists, are actually completely deterministic at the level of the overall quantum state. What looks like quantum randomness from our perspective is, in the many worlds view, the quantum wave function splitting into multiple branches, all of which are equally real and fully physically existent. Every outcome happens in a different branch of reality. In that picture, the block universe is even bigger and stranger than you might have imagined. It's not just one four-dimensional structure containing one history. It's an enormous, branching, multi-dimensional structure containing every possible history. All of them equally real. All of them already there. And you, your particular branch, your particular experience, are just one thread in that incomprehensibly vast tapestry, already woven, already there. The randomness of quantum mechanics in this interpretation doesn't mean the future is open. It means every possible future already exists in a different branch, all of them real, none of them more privileged than any other. That's either tremendously comforting or incomprehensibly disturbing, depending on the moment. Let me step back from the physics for a moment and talk about something that might actually be more immediately, personally unsettling than the block universe. Something that doesn't require you to think about four-dimensional space-time at all. The neuroscience, because even before we get to questions about the geometry of space-time, there is experimental evidence, hard, peer-reviewed, replicated experimental evidence, suggesting that the feeling of control you experience over your own actions may be, in some meaningful sense, a story your brain tells after the fact. The most famous experiment is the Libet experiment, conducted by Benjamin Libet in the early 1980s. Libet asked subjects to flex their wrist whenever they felt like it, completely spontaneously, no particular timing, just whenever the urge arose, and to note the position of a rapidly moving clock hand when they first felt the conscious urge to move. He also placed electrodes on their scalp to measure brain electrical activity associated with voluntary movement. What he found was genuinely startling. and it has been debated, criticized, and reinterpreted ever since, for good reason. But the core finding has held up. The brain activity that predicted and preceded the movement, what Libet called the readiness potential, a gradual buildup of electrical activity in the motor cortex, began approximately 550 milliseconds before the movement itself. But subjects reported their conscious decision to move, the moment they first felt the urge to flex, only about 200 milliseconds before the movement, which means the brain appeared to begin preparing for the movement before the person was consciously aware of deciding to move. The neural groundwork for the action was being laid 550 milliseconds before the action, while the conscious experience of deciding only appeared 200 milliseconds before. The decision seemed to happen at a neural level before the experience of deciding happened at a conscious level. Now, I want to be careful here. The Libet experiment has legitimate criticisms. What the readiness potential actually represents is contested. Whether the experimental paradigm captures anything meaningful about free will in the complex, deliberative sense we care about is genuinely questionable. The subjects were making split-second, trivial decisions, not the kind of deeply reasoned choices that matter most in our lives. But even with all those caveats, the experiment pointed at something important. It suggested that the conscious experience of deciding the moment you feel yourself making a choice may not be the initiating cause of the action. It may be the brain's narration of a process that has already begun at a subconscious level. The feeling of control, the sense that I am now, in this moment, freely choosing to do this, may be the story consciousness tells about something that happens at a level below conscious access. A report, rather than a command, a label the brain puts on a process it's already started so that you experience yourself as the author. This is deeply uncomfortable territory because the feeling of being in control is not just something we believe intellectually. It's one of the most vivid, immediate, fundamental features of conscious experience. The sense that right now, I am deciding, I am the one doing this. That feeling is as immediate as seeing color or feeling warmth. And the neuroscience is suggesting that it might be, at least partially, constructed post hoc, a narrative imposed on a process that doesn't require it. I noticed this in small ways that I can't quite unsee once I started paying attention to them. Like being in a conversation and realizing I've already started forming the response before I've consciously decided what to say, or going for a run and finding myself on a particular route before I recall deciding to take it. The body is often already doing something by the time the mind narrates it as a decision, which leads to a question that doesn't have a comfortable answer. If even the small, moment-to-moment feeling of deciding is constructed by consciousness rather than authored by it, what does that say about the larger question of control over our lives? Here's something strange and worth sitting with. If the block universe is real, if all of spacetime is a single static four-dimensional structure, then consciousness doesn't exist outside of it, looking in. Consciousness is part of it. Your experience of being here, in this moment, aware of this video, thinking whatever you're thinking, feeling whatever you're feeling, that experience is itself a feature of the block, not floating above it, not navigating through it from some privileged position outside, just in it, at a specific coordinate, part of the structure. The philosopher Julian Barber, who has thought about the relationship between time, physics, and consciousness as seriously as almost anyone alive, has a way of putting this that I find both illuminating and deeply strange. He talks about what he calls no's, the individual experiential moments of conscious beings. Each now is a particular configuration of the universe, a particular arrangement of all its components that contains within it memories of past configurations and anticipations of future ones. From the outside, If there were an outside, which there isn't, but imagine it conceptually, all these nows would simply be there, a vast collection of present moments, all existing simultaneously in the block, each one containing the subjective experience of being a self moving through time, each one filled with the vivid, urgent feeling of being in the present, of time flowing forward, of the future being open ahead, but none of them actually moving, all of them just there, all of them equally real, all of them equally present, in the sense that they all exist as coordinates in the block. You'd look at this structure, this vast four-dimensional tapestry of experience, and see billions of conscious beings, each feeling what feels like a flowing present, each convinced that their moment is the unique, special, real one, each experiencing the vivid sensation of time moving forward, and all of them would be right about their experience. The flowing present is real as experience, but the metaphysics, the idea that the present is uniquely real, that the past is gone and the future doesn't exist yet, that part might be wrong. Not because experience is wrong, but because the physical structure of reality doesn't match the phenomenological picture. Let me try to make this more concrete by doing something ambitious. Let's imagine stepping outside the universe. Not literally. You can't step outside space-time. There is no outside in the spatial sense. But conceptually, imagine we could somehow see the entire four-dimensional history of the universe at once, the way you can look at a whole book spread open rather than reading it one word at a time. What would we see? We'd see the Big Bang, that initial extraordinarily compressed, extraordinarily low entropy state at the beginning, a singularity that contained within its structure the seeds of everything that would unfold. We'd see the universe expanding outward from that point, protons and neutrons forming from the initial quark-gluon plasma, hydrogen and helium nuclei forming in the first minutes, the universe cooling, becoming transparent, releasing the cosmic microwave background radiation that we can still detect today, the oldest light in the universe. Then the Dark Ages, hundreds of millions of years of relative silence. Then, gravity pulling hydrogen clouds together into the first stars. We'd see galaxies forming, hundreds of billions of them, each containing hundreds of billions of stars. We'd see generations of stars living and dying, the massive ones exploding in supernovas that forge the heavy elements, the carbon, the oxygen, the iron, the calcium, and scatter them into the interstellar medium. We'd see those enriched clouds collapsing under gravity into new solar systems, carrying the raw materials of planets and, eventually, life. We'd see our sun igniting 4.5 billion years ago, a medium-sized yellow star in the outer arm of a medium-sized spiral galaxy. We'd see the Earth forming from the protoplanetary disk, the moon forming impact, the oceans accumulating, the first single-celled life emerging. We'd see billions of years of evolution, the endless branching tree of biological complexity, the Cambrian explosion, the dinosaurs, the extinction events, the rise of mammals. We'd see the thin, recent smear of human history, agriculture, cities, writing, science, war, art, everything, as a barely perceptible layer at the very surface of 4 billion years of life on Earth. And we'd see you, specific, individual, at a specific coordinate in space and time, every moment of your life, from birth to whatever comes at the end, already inscribed in the structure, already there, already part of the pattern, the conversations you remember, the conversations you've forgotten, the choices that felt momentous, the ones that felt trivial, the ones you haven't made yet. From the outside, if there were an outside, none of it is past or future. It's all just there, in the block, all equally real, all equally fixed. And here's the thing that I think is hardest to sit with. You wouldn't be watching this from outside. You'd be part of what's being watched. You'd be a feature of the structure, the sense of agency, the feeling of being a self that navigates, chooses, changes course. That feeling would itself be part of the pattern, not a bird flying over a landscape, a feature of the landscape itself. Now, I want to make something clear, because I've been building towards something that might sound nihilistic, and I don't think it is, or at least, I don't think it has to be. Determinism, the idea that the state of the universe at any given moment is determined by prior states, does not mean that your actions don't matter. This is the most common mistake people make when they first encounter these ideas, and it leads to a kind of paralysis that isn't warranted by the physics. The confusion is between determinism and fatalism. Fatalism is the view that no matter what you do, the outcome will be the same. If you're fated to fail the exam, you'll fail it whether you study or not. If you're fated to get sick, you'll get sick whether you exercise or not. Your actions are causally irrelevant. They're just motions in a play where the ending is fixed regardless of what the characters do. Determinism is completely different. In a deterministic universe, or in a block universe, your actions are part of the causal chain. The outcome is determined, but so are your actions, and your actions are what determine the outcome. The causal structure is fully preserved. Think about it this way. In the movie on the disc, the ending is fixed, but within the story, causes lead to effects. The characters' choices change what happens. The deliberation is real within the story. The effort matters within the story. The fact that it's all already on the disc doesn't mean the characters' choices within the story are meaningless. If the block universe is real, your choices are real features of it. The deliberation is real. The struggle is real. The effort is real. All of those are coordinates in the block, and they're also the causes that determine what comes at subsequent coordinates. The fact that it was always going to be this way doesn't mean you weren't the one making it happen. You are part of the mechanism. The mechanism runs through you. The meaning is in the experience, in the quality of the attention you bring to what you're doing right now, in the reality of the moment you're in, which is as real as any other coordinate in the block, in the fact that even if it's all fixed, the fixing runs through consciousness, through experience, through the richness of being here, in this particular moment, feeling what it's like to be alive. That's not a complete answer to the free will problem. I know that. Philosophers have been arguing about this for centuries and haven't converged on a solution, but it's a starting point for living with these ideas rather than being crushed by them. One of the places where the block universe becomes most emotionally resonant and most personally difficult is in thinking about the people we've lost. In the ordinary picture of time, when someone dies, they're gone, completely. The future no longer contains them. Everything they were, every thought, every feeling, every moment of their experience has simply ceased, vanished into nothing. The universe proceeds, and they are not in it. That's devastating, and it's the picture most of us carry with us through grief. But in the block universe, something is different. Not easier necessarily, not comforting in any simple sense, but different. When someone you love dies, they don't disappear from the block. Their entire existence, every moment of their life, is still there, inscribed in the structure of space-time. Every morning they woke up, every conversation, every laugh, every ordinary, unremarkable moment that felt like nothing at the time, all of it exists in the block the way a physical location exists on a map. Not gone, not erased, just at coordinates that you, from your current position in the structure, can no longer reach. The dead are not nowhere. They are somewhere. They are then, and then, in the block universe, is as real as now. I've been sitting with that idea for a long time. I'm genuinely not sure whether it's comforting or not. There's something in it that feels like permanence, like nothing is truly lost. Everything is preserved in the amber of space-time. Every moment, ever lived still existing somewhere in the structure. But there's also something that doesn't help with the actual experience of loss. Because the loss isn't about the objective existence of those coordinates. It's about the divergence of paths. You're at a coordinate in the block where they are no longer co-present with you. All the future coordinates you can reach no longer include them. The block still contains them, but you can't get there from here. It's a different kind of loss than the ordinary picture suggests. Not disappearance into nothing, more like permanent inaccessibility. The coordinates exist. You just can't visit them. I don't know what to do with that exactly, but it feels important to think about it carefully rather than just accepting the folk picture of death as total annihilation. Let me come to the question that I think is underneath everything we've been discussing. The question that the physics raises but cannot answer. The question that you probably came to this video already carrying, whether you knew it or not. Do you have control over your life? Not in the everyday practical sense. Of course, you choose what to have for breakfast and whether to exercise and how to treat the people around you. That kind of control is real and matters. I mean something deeper, something more fundamental, the sense that the future is genuinely open, that who you become is not already determined, that the choices feel like choices because they actually are choices in some deep, ontological sense, not just because your brain hasn't been told what's already fixed. Physics doesn't answer that question definitively. I want to be honest about that. The block universe, time dilation, the relativity of simultaneity, none of these things prove that your future is already fixed and that your sense of control is an illusion. The physics is compatible with several different philosophical interpretations. But here's what the physics does do. It makes the naive, comfortable answer much harder to hold. The naive answer, of course the future is open, of course time flows forward into genuine possibilities, of course I'm free. That answer was always resting on assumptions about the nature of time that, it turns out, are probably not true. The assumption that there's a universal now, the assumption that the past is gone and the future doesn't exist yet. The assumption that time is a river flowing in one direction, carrying us along. Those assumptions are contradicted by our best physics. Not probably wrong, probably fundamentally wrong, elegantly, quantitatively, experimentally wrong. And once you take seriously what the physics is actually telling us about time, that simultaneity is relative, that space-time is a four-dimensional structure, that the future might be as physically real as the past. The question of whether your choices are free, whether control is real, becomes much harder to answer in the way we want to answer it. Not impossible to answer, not clearly answered in the negative, but much harder. And that hardness, I think, is worth sitting with. A few weeks ago, I was walking home late at night through Cobble Hill. It was cold, properly cold, the kind of Brooklyn winter cold that clears your head whether you want it to or not. Past midnight, the streets were mostly empty except for a few people walking dogs and one group of laughing people spilling out of a bar. And there was this particular quality of light, the street lamps making everything amber and still, that made the whole street feel somehow outside of ordinary time, like a scene from a film that was already finished. And I thought about this, all of this, the block universe, the coordinates, the idea that this specific moment, this cold, this light, these particular people walking past, my particular thoughts in this particular arrangement, is already inscribed somewhere in the structure of space-time. Not just a memory that will fade, a coordinate that exists, that has always existed, that will always have existed. And I asked myself, is that beautiful or is it disturbing? And I genuinely think the honest answer is both, simultaneously both. There's something almost luminous about the idea that moments are not lost, that the things that have happened, The good ones, the important ones, the ordinary, irreplaceable ones, are not disappearing into nothing. They're part of a structure that doesn't dissolve. Permanently there, permanently real, in the same way that a place is real even when you're not in it. And there's something that resists this idea with something like everything, because being a person feels like moving forward into the open. The future feels like it's not decided. The choices feel like they're mine to make. The story feels like it's being written, not read. And the idea that all of that might be how consciousness experiences being embedded in a structure that is, from the outside, completely static, that idea bumps against something very deep. I don't have a resolution. I'm not going to offer you one because I think false resolution would be worse than honest uncertainty here. What I have is this. Physics tells us that time is not what we thought it was. The present is not uniquely real in the way it feels. Simultaneity is not universal. The structure of spacetime may contain everything that has happened and everything that will happen as part of a single, complete, unchanging whole. Consciousness inhabits that structure, experiences it from the inside, one moment at a time, unable to see the rest from where it stands, which means the question of whether you're free, whether the future is genuinely open or already fixed, may not be answerable from inside the block, because you can only ever see one slice of it at a time. You are always in the present, even if the present is not what it seems. Maybe time is not moving, maybe we are, or maybe, and this is the one I find hardest to dismiss, neither of us is moving. Maybe we're just there, at our coordinates, experiencing the vivid and urgent feeling of being here, right now, in this moment, in this particular configuration of a universe that contains every configuration at once. And the feeling of moving forward, the sense that the future is coming toward you, that you're navigating towards something open and unwritten, that the story is still being written and the pen is in your hand. Maybe that's not an illusion. Maybe it's just the only way consciousness can experience being fixed in a structure it can never see from outside. Maybe the feeling of writing is what reading looks like from the inside. The block universe doesn't mean nothing matters. If anything, it means the opposite. It means everything that ever matters. Every conversation, every effort, every moment of connection or joy or struggle or a beauty is permanently, indelibly inscribed in the structure of what exists, not disappearing, not fading, not gone when the moment passes, still there, still real, still part of the fabric of a universe that holds all of it. It's just that you can't see the whole book. You're always on the page you're on, and maybe that's the only way it could work. Maybe consciousness can only exist at one coordinate at a time. Maybe the experience of being alive requires not being able to see the whole structure. Maybe the story only works because you don't know the ending. Or maybe none of that is right. Maybe the future genuinely isn't there yet. Maybe the growing block is the correct picture, where the past and present exist, but the future doesn't. Not yet. And the present moment is a real edge, where reality is being created rather than revealed. We don't know. The physics doesn't settle it cleanly. The question is genuinely open in ways that matter. But I'll tell you what I do think. I think the naive picture, the one where time is obviously a river, and the present is obviously real, and the future is obviously open, and your choices are obviously yours. That picture is no longer available to anyone who has thought carefully about what relativity tells us. The comfortable default has been taken away. The floor has shifted. And standing on that shifted floor, taking seriously what our best science says about the structure of time and reality, that feels important. Even when it doesn't feel comfortable, maybe especially then. Physics does not give you a protocol for living with the block universe. It doesn't tell you how to think about your choices once you've thought carefully about whether choice is real. It doesn't give you back the comfortable certainty you had before. But I think there is something genuinely valuable in taking these ideas seriously, in sitting with the discomfort rather than turning away from it, in letting the strangeness of what physics is telling us actually land. What if you're not moving through time? What if time isn't moving at all? What if every moment of your life already exists, somewhere in the structure of a four-dimensional spacetime that has no now built into it? Only observers, each convinced they're in the only real moment, each experiencing the vivid and urgent sensation of being alive right here, right now. What if the future you're afraid of and the future you're hoping for are already there? What if the you who faces whatever comes next already exists at a coordinate you can't see? I don't know if that's true, but I can't stop thinking about it. And if you can't either, if these are the kinds of questions that keep pulling at you, that make ordinary moments feel strange and deep and worth sitting with, that make you look at your life differently and at time differently, and at the feeling of now with a kind of wonder mixed with something harder to name, then you might be exactly the kind of person who'd want to stick around. This is Novarium. We go to the places where science stops feeling comfortable, where the questions are bigger than the answers, where the universe, the deeper you look, just keeps getting stranger. If that's where you want to go, subscribe, because we're just getting started.